This is Miss Sec. This is a video for Foundations for Algebra Week 6. Okay. The problem that I want you to start off with in your math journal, I want you to solve this question. Miss Sec has $0. She gets $10 per week. Express this relationship as a table, ordered pairs, mapping diagram, graph, and as an equation. Miss Giles, please pause the video for 5 minutes. Miss Sec has $0. She gets $10 per week. So let's start this as a table. We're comparing weeks and how much money Miss Sec has. 0 weeks, she has $0. I'm doing it on the Jamboard, but I'm not showing it to you. In week 1, she gets $10 per week. So she has $10. In week 2, she gets $10 more, so she has $20. In week 3, she has $30. So the weeks increased by 1, and the money increased by 10. Now we're going to express this as ordered pairs. So as ordered pairs, this is 0, 0, 1, 10, 2, 20, and 3, 30. As a mapping diagram, when you have a mapping diagram, you have to put them in order from least to greatest, and the numbers cannot repeat. And then you draw an arrow from X to Y, from the input to the output. So in this case, the mapping diagram is very easy. When you draw a graph, you have to label the axes in words if you have a word problem. And you have to skip count by the same amount, which is easy in this problem because it is skip counting by the same amount. And as an equation, this would be y is equal to 10x. Why 10x? Because it's increasing by 10 each time. Today, we're going to learn about 2 different standards. The first standard we're going to learn about is 8F1. In this standard, we will describe how input and output diagrams represent rules and identify a rule that describes the relationship between input-output pairs and explain a strategy used for figuring out the rule. So I'm going to start this one with you. You can write on the slide. So we're going to use the input-output rule. 3/4, add 1, and then multiply by 4. So 3/4 plus 1, and then multiply by 4. 3/4 plus 1 is 7/4, and then we're going to multiply by 4, which is 7. So that's why the output is 7. 2.35 plus 1 is equal to 3.35, and then we're going to multiply 3.35 times 4 in our calculator. 13.4. You can do the last one by yourself. For the next one, we're going to take 3/4. Name the digit in the tens place. So the digit in the tens place is 7. So name the digit in the tens place for the next one. The digit in the tens place is 3. And then take the answer from this one that you solved and then name the digits in the tens place and put the answer here. Miss Giles is going to grade it. In the third one, it says 3/4, write 7. So you write 7. For the second one, you write 7. And for the third one, you write 7. For the evaluation, I want you to fill in the table for the input-output rule. 4, divide by 2, and then add 1. So I'll start with 0. So we have 0. Then you divide that by 2. So we're taking the input. We're taking the input. We're taking that. We're dividing it by 2, and then add 1. So I'm going to start it with you. Take 0, divide 0 by 2, which is 0, and then add 1. And 0 plus 1 is 1. So in the table, I'm going to put 1. Now please pause the video for 3 minutes, and I want the students to finish this problem. Okay, next. We're going to talk about standard 8F1. We're going to describe the properties of a function and distinguish between functions and non-functions using a variety of representations. We're going to orally identify whether or not the data represented is a function using technical vocabulary in complex sentences. Okay, so today we're going to talk about relations and functions. A relation shows a relationship between two values. A function is a relationship where every input has only one output. Okay. This one, which is 1-to-1, is a function. It's like the warm-up. When we drew the mapping diagram of the warm-up, every input had one output. This one is called many-to-1. You see, the output 4 has 2 inputs. This still is a function. An output can have more than one input, but an input cannot have more than one output. So these two are examples of relations that are not a function. So do you see 9? The input 9 has 2 outputs. That's why it is not a function. And the input 3 has 2 outputs. That's why it's not a function. I would like us to take some notes on this in our math journal so you can understand it better. Okay. This one is a function. A relation is a function if every input has exactly one output. So this is a function because all the inputs have one output. The output is 7. But this is not a function because for it to be a function, every input has to have exactly one output. And this input has more than one output. Now let's look at another example of a function. It's a function because every input has exactly one output. 1 goes to 5, 2 goes to 5. Each input has one output, but the output has more than one input. But this is not a function. This is not a function because the input 1 has more than one output. 1 goes to 5 and 1 goes to 9. Let's see what this looks like as ordered pairs. 1 goes to 5, 1 goes to 9, 2 goes to 8, and 3 goes to 9. You can see as ordered pairs, this is not a function because the input 1 has more than one output. Please pause the video for 1 minute so that the students can finish taking their notes. Okay. A function is a rule that assigns exactly one output to each possible input. Here's the function y is equal to 6x plus 4. It assigns one value of the output y to each value of the input x. For example, when x is equal to 5, then y is equal to 6 times 5 plus 4, or it's equal to 34. Okay. Using function language. A person is 60 inches tall. Do you know their height in feet? Since the answer to the question is yes, we can write a statement like height in feet depends on height in inches, or height in feet is a function of height in inches. These are the vocabulary words that we've talked about today. We've talked about relations. Relations are things that can be graphed. A relation is a function if every input has exactly one output. We talked about the input and output. Today, you were successful if you know that a function is a rule with exactly one output for each allowable input, and you know if a rule has exactly one output for each allowable input, then the output depends on the input. Today, Miss Giles will only grade 2 slides, 4 and 5. In the rest of the week, she will grade more than just 2 slides. Your independent assignment is to watch 3 videos and then do these 4 questions, evaluate functions. Now, you'll be you'll be using a different Khan Academy. So you're going to join Miss Giles' Khan Academy. So even though you may have done this with Mr. Allums, or you may have done this with Miss Nyawu, I want you, well, no, you guys, I'm thinking about her Math 8 classes. So you did this with me, the few students that did it, but I deleted your Google Classroom, and now I want you to join Miss Giles' Google Classroom. See you tomorrow. Okay. Hello. Good afternoon. I would like you to do this warm-up in your math journal. Please pause the video for 5 minutes. Okay. Miss Sek has $5. She gets $10 per week. Express as a table, ordered pair, mapping diagram, graph, and as an equation. So we're comparing the number of weeks with the amount of money. Miss Sek begins with $5. Every week she adds $10. So just like yesterday's warm-up, the weeks are adding by 1, and the money is adding by 10. But the equation is going to be different than yesterday's warm-up because this time Miss Sek begins with some money, where yesterday Miss Sek began with no money. So as ordered pairs, this would be 0, 5, 1, 15, 2, 25, and 3, 35. As a mapping diagram, the mapping diagram has to be in order from least to greatest, and the numbers cannot repeat. But that doesn't apply to this problem because the numbers are already in order from least to greatest and they already don't repeat. And this obviously, this relation is a function because every input has exactly one output. Now the graph is a little different than yesterday because you cannot put 5, 15, 25, 35 on the graph. No, that would be wrong. You have to skip count by the same amount. So I'm going to skip count by tens. But 0, 5 is not on my graph. So I'm just going to guess where 5 goes. 5 goes in between, halfway between 0 and 10. 1, 15, 2, 25, and 3, 35. So I'm just kind of approximating where they go. And as an equation, this is y is equal to 10x, just like yesterday. Yesterday's equation was y equals 10x because it's increasing by 10 every week. But this time, we have to incorporate the fact that you're adding 5. I mean, you begin with 5. Miss Sek begins with $5. So we're going to say plus 5 because Miss Sek began with $5. Today, we're going to be working on standards 8, F1, and an algebra standard. That's actually the difference between Foundations for Algebra and Math 8. Foundations for Algebra has some high school standards included. So the algebra standard is FIF1. So today you will understand the domain and range of a function, orally identify whether or not the data represented is a function using technical vocabulary and complex sentences. And our vocabulary words today are domain, range, and function notation. Determine if each statement is true or false. Explain your reasoning. So let's review what the definition of a function is first. So a relation is a function A relation is a function if every input has exactly one output. Please pause the video for 2 minutes so the students can answer these questions, and then I'll explain the answer. Every function is a relation. So this is false because a relation is only a function. Oh, every function is a relation. No, that's true. But every relation is a function. No, that's not true because a relation is only a function if every input has exactly one output. So this is false. When you switch the inputs and outputs of any function, the resulting relation is a function. So this is false because a relation is only a function if every input has exactly one output. The presence of repeated input values determine if a relation is a function. This is true because remember yesterday we had said if an input has two outputs, then it's not a function. And the values of the outputs do not determine if the relation is a function. That's also true. Okay. So let's go over this slide together. Okay, we're exploring a relationship of two ordered pairs. Okay. So you need to name a coordinate is written in the form x comma y. The variables in math and science are x comma y. A function rule is a process that converts an input to an output. The set of inputs and the set of inputs and the set of outputs of a mapping diagram are x comma y. Okay. Today we're going to learn two new vocabulary words. The new vocabulary words are domain and range. The domain is the set of input values, the independent variable of a function or relation, and the range is a set of output values, the dependent of a function or relation. So I would like you to I would like us to take some notes on one of these. So let's look at what domain and range means for this. So the domain is all the x values and the range is all the y values. Let's write this down. The domain is all the x values and the range is all the y values. So the domain of this problem is all the x values. So the x values, you have to put them in order from least to greatest, and they can't repeat. So -6, -1, 1, 5, and 7 are the domain, and the range is all the y values, -4, -1, 2, and 4. So let's do this problem together. Let's talk about the domain and range from a table, a mapping diagram, and ordered pairs. Okay, so the domain is all the inputs. So this would be our domain, and this would be our range. All the inputs are the domain, and all the outputs are the range. And the numbers have to be in order from least to greatest, and they can't repeat. So 0, 1, 2, 3, and 4 are the domain. And notice the output, the numbers are going down. So we can't put them like that when we talk about the range. We have to put them in order from least to greatest. And the numbers can't repeat. 1, 3, 6, 9, and 12. Now, is the relation a function? Well, the relation is a function if each input has only one output. So the input actually doesn't repeat. So the answer is yes. And the reason why is every input has one output. Now, let's look at the domain and range for the mapping diagram. So the domain from least to greatest is -9, -2, 5, and 12. And the range, notice there are only 3 numbers in the range because 5 and 12 have the same output. Now, is this a function? Well, even though the output has 2 inputs, that's still a function. So every input has one output. So the answer is yes. And the reason is the same. Every input has one output. Now, the domain for ordered pairs, remember the domain cannot repeat. So in this case, the domain does not repeat. But if there's more than one domain, you cannot write it multiple times. You just write it once. And the range, is this relation a function? Yes. None of the domains repeat. So the relation is a function. And the reasoning is the same reason. So please write the answer. Okay, now what I'd like you to do, and Miss Ballard is going to grade it, is I would like you to determine draw a line between function and not a function. Is it a function or is it not a function? Please pause the video for 4 minutes and then continue again so the students can answer this question. Now we're going to talk about standards 8F1 and FIF1. Students will understand the domain and range of a function, explain whether or not the data represented is a function using technical vocabulary and complex sentences. Now, a relation contains the ordered pair shown. One of the ordered pairs is missing in the x-coordinate. What could be the missing x-coordinate if the relation is not a function? I will talk you through this and allow you to answer this. Okay, so the domain -1, 0, 2, 3. For this to not be a function, the inputs have to repeat. So give me an answer so that this is not a function. Now, I would like you to write the domain and range of your answer. Please pause the video for 4 minutes so the students can answer this question. Okay, now we're going to do this problem together, part of it together. For the first 10 days of the month, you record a high temperature T in degrees Fahrenheit. Each day, the results are shown in the table. Let D be the input and T be the output. Is the relation a function? Explain if the relation is a function, write the domain and range. Okay, so I'm going to do this with you. The relation is a function because the domain does not repeat. You might want to do part of this in your journal to finish this. Okay, is the relation a function? Yes, the relation is a function. The relation is a function because every input has exactly one output. And write the domain and range. So I'm going to do this with you and start you for the second question, but then Miss Giles is going to grade the second question. 1, 2. So this is the domain. But then for the range, you have to find the smallest number. So the smallest number is 61 and the biggest number is 76. So 61 is the smallest number. And then you notice 61 repeats. Then the next number is 62. Then the next number is 64, but 64 repeats. Oh, the smallest number is 57. The smallest number is not 61. Now the next number is 65, then 66, and finally 68. Now for question 2, let T be the input and D be the output. Is the relation a function? So we're going to switch it. You might want to write this down in your journal to be able to answer this question, or on the slide. That's fine. Okay, now, is the relation a function? Is it still a function? And then write the domain and range. Please, Miss Giles, please pause the video for 5 minutes so that the students can answer this question on the Pear Deck. Okay. Today, you should be able to identify the domain and range of a relation or a function, and you can explain how to use the domain to determine if a relation is a function. Miss Giles is grading slides 17, 18, 20 through 25, much more slides than yesterday. She only graded 2 slides yesterday. And your independent assignment is Khan Academy, the work example evaluating. This is the video. The video is a work example evaluating functions for a graph. And then you're going to answer 4 questions evaluating functions from their graph. See you tomorrow. Okay. We are going to go to Clever. You type in clever.com/in/PGCPS. and then go to Speak Agent. I'm going to type in Speak Agent. I would like you to go to Foundations for Algebra Unit 2A. Now, you don't see your class in there like I have you in my grade book, but I don't have you in my Speak Agent grade book. I would like you to do word list today. Foundations for Algebra 2A, defining functions. So that's what's being graded today. I will see you tomorrow on Thursday. Hello, students. Today is Thursday. I would like you to do this warm up in your journal. Miss Sec has $50. She spends $10 per week. Express as a table, order pairs, mapping diagram, graph, and as equation. Please pause this video for 5 minutes and I'll go over the answer. Okay. On week 0, Ms. Sec has $50, and then she spends $10 per week. So on week 1, I have $40, week 2, $30, week 3, $20. The weeks are increasing by 1, but the money is decreasing by 10. As ordered pairs, this is 0.50, 1.40, 2.30, and 3.20. As a mapping diagram, we're going to do inputs and outputs. The inputs are increasing, but I want you to notice the outputs are decreasing. So since the outputs are decreasing, we're going to put them in order from least to greatest. And remember, the numbers cannot repeat in a mapping diagram. We're going to draw an arrow from the inputs to the outputs. Now, as a graph, we're going to skip count by tens on the y-axis. Remember to label these in words. Okay, oh, I should have gone to 50. 0.50. Okay. Now write it as an equation. Okay, now the money is decreasing by 10 every week, so it's negative 10x. And how much did I begin with? I began with $50. So since I began with $50, I'm going to add 50. So negative 10x plus 50. Today, we're going to talk about standard 8F1. We're going to calculate the output of a function for a given input using an equation in two variables and interpret the output in context, create an equation that represents a function rule, determine the independent and dependent variables of a function, and explain the reasoning. Today, you should be able to find the output of a function when you know the input, and you can name the independent and dependent variables for a function with an equation. Let's find outputs from equations. So an independent variable is an amount that is used to calculate another amount. The independent variable represents the input of a function. A is the number of apples, that's the input, and the output is the number of bananas. The input is on the left side and the output's on the right side. We need to buy 20 pieces of fruit and decide to buy apples and bananas. We select the number of apples first. The equation B equals 20 minus A shows the number of bananas we can buy. The number of apples is the independent variable because we can choose any number of it. A dependent variable represents the output of a function. A is the number of apples, 20 minus A. B is the number of bananas. We need to buy 20 pieces of fruit and decide to buy apples and bananas. If we select the number of apples first, the equation B equals negative 20 minus A shows the number of bananas we can buy. The number of bananas is the dependent variable because it depends on the number of apples. Okay. So the two vocabulary words that we're talking about independent variable. These are notes. The independent variable is the input, and the dependent variable. The dependent variable is the output. The independent variable is represented by the letter X, and the dependent variable is represented by the letter Y or by f of X, which we're going to talk about today. The independent variable is on the horizontal line of the graph, the x-axis, and the dependent variable is the vertical line of the graph. Please pause the video 1 minute. So that the students can copy this page. Okay. So we just took some notes. Okay, now. S is if we have the area of a square, okay? The side of the square is S. S is the independent variable, and A, which represents area, is the dependent variable. We say A depends on S. So I would like us to do this together. I'm going to read it to you, then I'm going to ask Miss Giles to pause the video for 5 minutes, and then we're going to go over the answers. Okay, match each of the descriptions with a diagram. So these are the descriptions. These are the input-output tables. So you're going to match the descriptions with the diagram. Write an equation for each description that expresses the output as a function of the input. Find the output when the input is 5. Name the independent and dependent variables of the equation. So you're actually going to do this on the next slide, on slide 38. But we're going to talk about this before you do slide 38. So please pause the video for 5 minutes. Okay, now A, the circumference C of a circle with the radius R. So this D and A, they match. Okay, so what is the formula? The formula is circumference is 2 times pi times the radius. B, the distance in miles, D, that you would travel in T hours if you drive 60 miles per hour. So this B matches with B. So this would be D is equal to 60 times T. C, the output when you triple the input and subtract 4. So C matches with C. The output when you triple the input and subtract 4. And then D is A. This is D. The volume of a cube with it given the edge length S. So S cubed. Volume is S cubed. So what you're going to do is what you're going to do is we wrote the equation and then find the output when the input is 5. So for A through D, we have the equation. You can make a screenshot of the diagram. So you can take a screenshot of the diagram on slide 37 and then paste that screenshot of the diagram here. And then write the equation. And then when the input is 5, what is the output? For example, for letter D, it's V is equal to S cubed for letter D. So the input is 5. So it's V is equal to S cubed. So 5 cubed. Well, what is 5 times 5 times 5? The output V is equal to 125. So the equation is V is equal to S cubed. The diagram, you would go back to the previous slide. You go back to the previous slide and take a screenshot and just put it on the next one. And then what is the independent and what is the dependent variable? Then you can write your answer. So the independent variable is the side length S, and the dependent variable is the volume cubed. So I would like you to pause the video for 5 minutes and let the students finish this. Okay, we're going to talk about standards 8F1 and 8F3. Students will determine whether a graph represents a function and explain the reasoning, identify the graph of an equation that represents a function and explain the reasoning, interpret points on a graph, including a graph of a function and the graph that does not represent a function. Today, you will be able to identify graphs that do and do not represent functions. You can use a graph of a function to find the output for a given input and find the input for a given output. Okay. Kate, Bianca is on the track. The graph shows her time given how far she is from the starting point. What is her farthest distance from her starting point? So the farthest distance from her starting point is this number. So you have to we're skip counting by 25s. So this number is 200. Estimate how long it took her to run around the track. So how many it took this amount of seconds to travel to the furthest point and then to go back. So how many seconds is that? That's a little more than 72 seconds. So make a guess. Estimate how long it took her to run around the track. Whatever this number is what you should write. Estimate when she was 100 meters from the starting point. So we go to 100 meters. She was 100 meters from the starting point at this number. So what is this number? And at this number, I want you to guess what this number is. Remember, this number is in between these two numbers, so make a guess. Estimate how far she was from the starting point after 60 seconds. So we go to 60 seconds, this number, and we go to 60 seconds and this number. Is Bianca's time a function of her distance? Is her time a function of her distance? So this is the x is the distance. So we see that the distance is not a function of the time because every input does not have exactly one output. But is the time a function of its distance? Does every time have exactly one distance? So you can answer that and explain. That will be graded. Please pause the video for 5 minutes so the students can finish answering this question. Okay, the standards that we're talking about are 8F1 and 8F5. Describe a graph of a function as increasing or decreasing over an interval and explain the reasoning. Interpret a graph of a temperature as a function in time using language such as input and output. Okay, which graph does not belong? Please pause the video for 2 minutes so the students can determine which graph does not belong. So I would say that graph B does not belong because it is not a function. So if the input has more than one output, but in this one, every input has exactly one output. Okay, let's interpret graphs of functions. Exploring time and temperature. Okay. The graph shows the temperature between noon and midnight in one day in a certain city. Was it warmer at 3 p.m. or at 9 p.m.? So let's go to 3 p.m. and 9 p.m. So at 3 p.m., it was less than 55 degrees, and at 9 p.m., it was about 56 degrees. So it was warmer at 9 p.m. It was warmer at 9 p.m. Approximately when was the temperature the highest? Well, the temperature was the highest at this point. So what was the temperature? It was around 59 degrees. And what time was that? That was right before 6 o'clock. Find another time the temperature was the same as it was at 4 o'clock. So at 4 o'clock, it was about a little more than 57 degrees. And at this time, it was about 57 degrees. So that's right before 8 p.m., around 8 p.m. Did the temperature change more between 1 and 3 p.m. or between 3 and 5 p.m.? So 1 and 3 p.m. and 3 and 5 p.m. So when did it change more? So we're looking for how much did it increase the most? It went from about 50, a little more than 50, about 50, no, about 40, 50.5 to 54.5. So 50.5 and 54.5. So that's about 4. So it increased by about 4 degrees Fahrenheit. And then from here, it went from about 54.5 to about 58. So this is 3.5 degrees. So what the question is, did the temperature change? When did the temperature change more? So the temperature changed more between 1 and 3 p.m. Does the graph show the temperature is a function of time or that time is a function of temperature? So it shows that time is a function of temperature because input has exactly one output. I can't read the last question. Okay. Today you should have been able to explain the story told by the graph of a function. Today, Miss Giles is going to grade slides 37, 38, 41, and 47. Your independent assignment is to watch these 3 videos on Khan Academy and to answer function rules from equations. Please solve this warm-up in your journal. Miss Giles, please pause the video for 5 minutes so the students can answer this warm-up. On week 0, Miss Sec has $100, and then she's spending $15 every day. So money is going down. $15, I mean every week, not every day. So the weeks are increasing by 1, and the money is decreasing by 15. We can express these as ordered pairs. We can write a mapping diagram. Remember, in a mapping diagram, the orders increase from least to greatest, and the numbers cannot repeat. So even though this is going downwards, we're going to put the output in order from least to greatest. And then you draw an arrow from the input to the output. In the graph, you have to skip count by the same amount for the output. So, and the input and the output. So I'm going to skip count by 25s. You cannot put these numbers on the graph. If you put these numbers on the graph, your graph is not right because you have to skip count by the same amount. So 0, 100, 185. I'm just guessing where they go. Okay, now. And as an equation, it's y is equal to negative 15x because the money was decreasing by 15 every week, plus 100. And it's plus 100 because Miss Sec began with $100. Today, we're talking about standards 8F2 and 8F3. Today, we will compare and contrast representations of functions and describe the strengths and weaknesses of each representation. We will interpret multiple representations of functions, including graphs, tables, and equations, and explain how to find information in each type of representation. Today's goal is to compare inputs and outputs of functions that are represented in different ways. Let's connect tables, equations, graphs, and the stories of functions. Okay, we're going to do this one together, and then I'm going to allow you to work on problems. Work on the next problem. Okay, the graph shows the temperature between noon and midnight in city A on a certain day. The table shows the temperature T in degrees Fahrenheit for hours after noon in city B. Which city is warmer? Okay, so I'm going to go over this one. I'm going to grade the middle one, slide 56, and I'm going to go over slide 57. Okay. Which city is warmer at 4 p.m.? So to be able to answer this question, oh, let's look at my Jamboard. Okay, I'll go to 4 p.m. So for graph A, 4 p.m. is 57 degrees Fahrenheit. But for B, for table B, it's 62. So which city is warmer? It's city B. Which city has a bigger change in temperature between 1 and 5? So between 1 and 5, the change in temperature goes from 50 to 57. So it's 7 degrees Fahrenheit. Between 1 and 5, between 1 and 5 on the table, it's changing between 82 degrees and 58 degrees. So that's 24 degrees. So which one had a bigger change? It was B that had a bigger change because 24 is bigger than 7. How much greater was the highest recorded temperature in city B than the highest recorded temperature in city A during this time? So how much greater? Well, we're talking about 24 degrees, but it was negative. It changed in a negative way. 24 degrees and so negative 24 degrees and 7 degrees. Oh, no. I read the question wrong. How much greater was the highest recorded temperature in city B with the highest recorded temperature in city A? So the highest recorded temperature in city B was 82 degrees. And the highest recorded temperature in city A is 59 degrees. So 82 degrees minus 59 degrees, we're just going to subtract 23 degrees. And compare the outputs of the function with the input 3. So the input 3 for A, input 3 for A is 55 degrees. And input 3 for B is 75 degrees. So if we want to compare them, you could say that city B has a higher temperature than city A, or you could say city A has a lower temperature than city B. Okay, I would like you to spend 5 minutes of quiet answering slide 56 by yourself. Please pause the video for 5 minutes. Slide 56 will be graded. Slide 57, let's do slide 57 together. Okay, the volume V of a cube with the side length is given by the equation V equals S cubed. The graph of the volume of the sphere as a function of its radius is shown. Is the volume of a cube with the side length S equals 3 greater or less than the sphere with the radius 3? So we're comparing, this is the volume of a sphere. So we're comparing the volume S cubed with the volume of the sphere. So the volume of a cube with the side length 3 would be V is equal to 3 cubed, which is 27. So we're comparing this with 3 on this graph. So 3 on this graph is about 100, is between 125 and 100. So it's about 100 and, let's say 115. So which one is greater? Well, the sphere is greater. Estimate the radius of a sphere that has the same volume as a cube with the side length 5. So the volume of a cube with the side length 5 would be 5 cubed, which is 125. Estimate the radius of the sphere and that has the same volume. So the radius of the sphere that has the same volume of 125. So we're looking for 125, a volume of 125. What is the radius? So let's go to 125. 125 is here, 125. So let's find the radius. The radius here is about 3.25. Compare the outputs of the two volume functions when the inputs are 2. So the volume is 2 cubed, which is 8. That's of a cube. And when the input is 2, here, what is the output? The output, we go to the graph, the output is about, let's say, 45. So we're talking about a volume of 8 versus the volume of 45. Today, you should have been able to compare inputs and outputs of functions that are represented in different ways. Today, Ms. Giles will grade slides 52, 55, 56, and 57. Your independent assignment is a quiz assessment. See you on Monday.